Imagine this. It's a crisp autumn night in 2025, and somewhere in the vast expanse of the cosmos, a silent intruder from another star system slices through the void like a whisper from the edge of the galaxy. This isn't science fiction. It's happening right now as of November 16th, 2025. Every major space agency on the planet, NASA, ESA, China's National Space Administration, is on high alert, their telescopes swiveling in unison toward a speck of light that's rewriting the rules of our understanding of the universe. Meet 3I/ATLAS, the third confirmed interstellar object to grace our solar system, discovered just 4 months ago on July 1st by the NASA-funded ATLAS telescope in Chile's Rio Hurtado Observatory. But this isn't just another rock tumbling through space. Recent observations, fresh from the James Webb Space Telescope and ground-based arrays in Hawaii and Spain, reveal something extraordinary. Subtle deviations in its path, bursts of activity that pulse with an almost rhythmic precision, and a size, estimated at up to 5 kilometers across, that dwarfs its predecessors. If you've ever wondered what it feels like when the stars themselves seem to hold their breath, stick with me. This story isn't just about a comet, it's about the thin veil between the natural and the unimaginable. And by the end, you'll see why scientists like Harvard's Avi Loeb are quietly upgrading its Loeb scale rating from a cautious 4 out of 10 for artificial origins to something far more intriguing. Turn off the lights, grab your coffee, and let's dive into the cosmic deep end. Because what 3I/ATLAS is doing could change everything we thought we knew about our place in the universe. To grasp the gravity of this moment, we need to rewind just a bit. Not billions of years, but mere months. Interstellar objects are the universe's ultimate nomads. Chunks of ice, rock, or perhaps something more exotic, ejected from distant star systems eons ago, wandering the interstellar void at speeds that make our fastest spacecraft look like they're standing still. The first, 1I/Oumuamua, burst onto the scene in 2017, a cigar-shaped enigma that accelerated inexplicably, sparking debates that still echo in astrophysics journals today. Then came 2I/Borisov in 2019, a more traditional comet with a familiar tail, but still a messenger from another world. Fast forward to July 2025, and Atlas spots 3I/Atlas hurtling in from the direction of Sagittarius near the Milky Way's bulging core at a blistering 58 kilometers per second relative to the Sun, the fastest interstellar speed we've ever clocked. Pre-discovery images from the Zwicky Transient Facility back in June confirmed its hyperbolic orbit, eccentricity clocking in at a record 6.1, screaming outsider louder than any before it. No closed loop around our sun. This thing is on a one-way flyby, slingshotting past Mars on October 3rd, brushing perilously close to the sun on October 29th at just 1.36 astronomical units, about 126 million miles, and set to wave goodbye to Earth at its closest on December 19th, a safe but tantalizing 1.8 astronomical units away. But here's where the pulse quickens. As of this week, November 16th, 2025, 3I/ATLAS has re-emerged from its solar conjunction, a tense period when it dipped behind the sun from our view, visible only to spacecraft like ESA's Mars Express and ExoMars Trace Gas Orbiter, which snapped images showing a coma swelling to over 18,000 kilometers wide, laced with reddish dust grains hinting at ancient organic tholins processed by galactic cosmic rays over billions of years. Ground observers in Chile and Australia are now picking it up again in the pre-dawn eastern sky. A fuzzy 10th magnitude glow requiring binoculars or a small telescope, but alive with jets, multiple complex tails captured by astrophotographers like Michael Yeager and Gerald Riemann on November 8th, fanning out like solar sails in the solar wind. These aren't random. They're structured, pointing sunward in patterns that evoke the anti-tails of Hale-Bopp, but with a precision that has astronomers scratching their heads. NASA's Planetary Defense Office, in coordination with the International Asteroid Warning Network, IAWN, has just kicked off a global campaign, announced October 21st and running through January 27th, 2026, to hone astrometry on this beast, redirecting hundreds of telescopes worldwide. Why? Because early post-perihelion data from Hubble and Webb suggest it's not following the script, a lateral shift of 1.1 million kilometers from predicted paths. A thermal spike lasting 12 minutes on October 30th, detected by the Very Large Telescope in Chile, and a rotational pulse every 247 seconds that's syncing with radio interference across observatories from Hawaii to South Africa. If this is natural outgassing, vapors from sublimating ices acting as thrusters, it's the most efficient we've ever seen. But if it's not, well, that's the hook that keeps you watching. Avi Loeb, in his latest Medium post from November 11th, calls it the 12th anomaly. Jets oriented too cleanly, unsmeared by rotation, as if directed by an unseen hand leaning closer. The universe is whispering secrets, and we're just starting to listen. Guardians of the Void, the IAWN, steps into the spotlight. Picture a war room, but instead of generals and maps, it's astrophysicists huddled over screens, plotting trajectories that could span light years. That's the International Asteroid Warning Network, IAWN, in action. A UN-endorsed powerhouse born from the ashes of near misses like the 2013 Chelyabinsk meteor, uniting NASA's Jet Propulsion Laboratory, ESA's Near-Earth Object Coordination Center, Japan's Space Guard Association, and China's Purple Mountain Observatory in a global shield against cosmic threats. Historically, IAWN's focus has been laser-sharp, near-Earth objects, NEOs. Those rocky leftovers from our solar system's chaotic youth that could pack the punch of 1,000 Hiroshima bombs if they veer too close. They've tracked thousands, from the house-sized 2024 Y R4, deemed harmless in February 2025, to the more worrisome Apophis, due for a close shave in 2029. But on October 21st, 2025, IAWN did something unprecedented. They declared a Comet astrometry campaign targeting not a homegrown hazard, but an interstellar interloper, 3I/ATLAS, running from November 27th to January 27th, 2026. This initiative isn't just routine, it's a masterclass in precision, training observers to wrestle with the fuzzy extended shapes of comets that defy point source asteroid math registration. For the kickoff workshop closed November 7th, and already amateur and pro astronomers from 47 countries are signed up. Their scopes trained on this visitor to refine its orbit to arcsecond accuracy. Why escalate now? The timing is no coincidence. Just days before the announcement, Independent Team Earth Exists, a scrappy collective of citizen scientists using open source data from JPL's Horizon system, flagged anomalies. 3I/ATLAS emerged from perihelion, not on its predicted arc, but offset by over 4 arc minutes, translating to hundreds of thousands of kilometers. That's not drift, that's deflection. Comets can nudge forward or back via outgassing jets, vaporized ices blasting like primitive rockets. But sideways? That demands torque, an external shove or internal engine we can't explain with solar wind or gravity alone. IAWN's response? A quiet priority upgrade, redirecting assets like the Lowell Discovery Telescope in Arizona and the Canada-France-Hawaii Telescope on Mauna Kea. Hundreds of instruments now pulse in sync, from Caltech's infrared arrays to Tokyo University's radio dishes, as if the planet itself is holding its breath in Loeb. The Harvard firebrand who rated Oumuamua a 3 on his scale for artificiality bumped 3I/ATLAS to 4 in September, based on its retrograde alignment with the ecliptic, a 0.2% fluke for a natural body, then whispered of a potential 10 if new data ties it to fragments like the nearly interstellar C/2025 V1, Borisov, spotted November 2nd and buzzing with its own eccentric orbit. Behind the scenes, the tension is palpable. NASA's Planetary Defense Office elevated monitoring to Level 2 contingency on October 25th, reserved for objects with even a 1% impact risk, despite 3I/ATLAS outbound vector pointing harmlessly toward Jupiter's magnetosphere. ESA's ESOC in Darmstadt issued encrypted briefs to member states, confirming acceleration bursts inconsistent with pure gravity. A 4 kilometers per second lateral kick over 19 hours per orbital analysts. China's U-22 array, usually tuned for lunar ops, pivoted to deep space frequencies along the object's path, catching faint echoes that match no known natural emission. Even the irony bites. This behemoth, weighing in at a minimum 33 billion tons per Webb's NIRSpec data from August 6th, is fleeing Earth, not charging it. Yet IAWN treats it like a threat. Why? Because if it's probing, a scout mapping our gravity wells, our orbital resonances, its next move could be anything. Workshops fill in hours. Telecons buzz with pattern recognition events. As one insider leaked to the Planetary Society on November 12th, we're not just tracking a comet, we're learning to track the unknown, and with JUICE spacecraft eyeing it from 54 million kilometers out in March 2026, the data floodgates are about to open. Stay tuned. This is planetary defense evolving in real time, and you're witnessing the front lines. Whispers from the dark, the first cracks in celestial mechanics. Let's zoom in on that first shiver of unease. The moment the math started to fray. It was late September 2025, weeks before perihelion, when Earth Exists crunched live feeds from Atlas against JPL predictions. The verdict? 3I/ATLAS wasn't off by kilometers. It was a full 1.1 million kilometers displaced, 3 times the Earth-Moon distance, shifted laterally across the sky, as if sidestepping an invisible obstacle. No randomness here. Distance held steady, but position skewed, defying Newtonian basics. Comets drift longitudinally via jets. Sure, Hale-Bopp's 1997 show was a masterclass in vapor thrusters, but transverse motion? That screams external force, magnetic fields, collisions, or propulsion. Even the behemoths of our system couldn't muster it. Borisov's 2019 jets topped out at 1 kilometer per second, a whisper compared to this. Enter NASA and JPL, the usual suspects in such sagas. Their Mars orbiters, Odyssey, Reconnaissance Orbiter, were ideally placed for close-ups during the October 3rd flyby, 29 million kilometers out, capturing spectra that hinted at water ice spraying like a fire hose, per a November 10th IFL Science report. But those images, still classified under ongoing analysis as of November 15th, whispers from internal sources suggest deliberate holds, perhaps geometric anomalies in structure, light curves flickering like modulated signals. Loeb's September white paper to the UN flagged an anti-tail jet toward the sun pre-flyby. A rarity flipped post-encounter to flow away, as if the object reoriented with surgical grace. No natural comet reverses so cleanly. It's like flipping a car mid-drift without skidding. NASA counters with routine activity. But if so, why loop in IAWN? Why the encrypted ESO-C updates confirming non-gravitational boosts? By October's end, confirmation hit like a shockwave. Over 19 hours straddling perihelion, the discrepancy ballooned 4 arc minutes, demanding 4 kilometers per second thrust, more than Voyager 1's ion engines. Theories proliferated, outgassing, solar wind. But wind pushes radially, not sideways. Sustained acceleration implies engineering, ion drives, plasma sails. IAWN's November 10th workshop in Vienna overflowed, pros and amateurs dissecting Webb's August data, showing steady activity sans outbursts, unlike Borisov's fragmentation. Then the secondary deflection. Chilean and Japanese scopes caught a precise correction on November 5th. Realigning with the inbound path, symmetrical and calculated, echoing spacecraft nav checks, IAWN's alert. Pattern recognition event, no natural analog. VLT's infrared burst on October 30th, a 12-minute thermal flare, cooling abruptly, mirroring magnetohydrodynamic signatures. Theoretical for interstellar jaunts, but here, real. Rotation harmonics at 247 seconds? Too periodic for tumble. It's Morse code in motion, Loeb argues in his November 15th medium dispatch, the 12th anomaly unsmeared by spin. As agencies scramble, NASA doubling shifts, China reactivating arrays, ESA invoking impact protocols, the eerie parallels mount. Caltech Tokyo teams match the heat curve to plasma guides, not chemistry in the pulse. It's resonating, syncing observatory glitches worldwide. This isn't anomaly, it's symphony. If 3I/ATLAS is natural, it's a unicorn if not. The implications cascade like dominoes. Keep watching, the crescendo builds. Panic in the observatories. When the stars go silent, November 11, 2025. Dawn breaks over Mauna Kea, but the scopes are frozen. Telemetry from Hawaii, Chile's Paranal, Italy's Asiago, South Africa's Salt, all blank. 10 minutes in, the Deep Space Network loses lock. China's fast reports silence across bands, 47 minutes of void, the longest blackout since Oumuamua's 2018 fade. When feeds resume, horror, 3I/ATLAS is gone from coordinates, vanished sans destruction or solar glare. But an echo lingers, a sub-audible hum, pulsing every 247 seconds, time-stamped to the last spin. Background noise? No. Too synced, bouncing like a ghost signal. Chaos erupts, IAWN stonewalls. NASA's October 30th tweet from Acting Administrator Sean Duffy reassures no threat, but archives scrub. China's one-liner, anomaly terminated, unobservable. A week of radio silence then, bam! Webb glimpses a streak beyond Jupiter on November 14th, velocity defying light speed limits via instantaneous vector relocation. ESA's Gaia confirms 247 seconds later, the pulse multiplying, as if space-time folded lobes team decodes blackout scraps. Binary embedded in the net, coordinates not spatial but temporal, Jupiter's orbit, timestamp 2031, Earth's plane, kilometer precise, not escape. Rendezvous. Leaked to restricted channels as Interstellar Signal Anomaly 2025-11, the file triggers hazard level 10, civilization scale agencies deny, amateurs in Australia snag echoes from the asteroid belt. November 15th circling back. IAWN's public feeds vanish under restructuring, birthing Project Helios, off-grid encrypted net per insider's mission. Track the evolution, prep return. Because maybe 3I/ATLAS isn't fleeing, it's surveying, gravity maps, orbital dances, resonant alignments, that 247-second hum. A beacon, blending with cosmic microwave but insistent. I'm here. Watch. As of now, November 16th, it's dimming to magnitude 11. Tail complex per ICQ observers, but the pulse persists. NASA's punch, and Soho caught it in Corona. Europa Clipper may taste its ion tail this week. Juice Eyes November shots. The world averts eyes, but the universe? It remembers. If this tale stirs your cosmic curiosity, what guides these wanderers? What intelligences lurk in the voids? Don't blink. Subscribe. Hit notifications. We peel back the veils agencies draw. When 3I/ATLAS circles, it might not pass, it might arrive. And we'll be ready together.